next we are going to discuss about one another property. If we have a Laplace transform of a ft, any function, then how we find the Laplace transform of t into ft, t square into ft, t cube into ft means multiplied by an integral power of a t in a ft. Means if we have a Laplace transform of ft, then how we find the Laplace transform of ft multiplied by integral power of a t. So, here we write this property as a multiplication by positive integral power of a t. What is the property? If ft is a function of a class A means a Laplace transform of a ft, sufficient condition of existence of a Laplace transform. So, this one have only meaning ft have a Laplace transform, existence of a surety of a existence of a Laplace transform, nothing else. So, if Laplace transform of ft is a fs, then Laplace transform of t into ft is a minus f dash s. So, in a simple language we say that if Laplace transform of ft is a fs, then Laplace transform of t into ft equal minus f dash s if Laplace transform of ft will exist. So, how we prove this one? Laplace transform of t ft equal minus f dash s. So, what is the given? Given is a Laplace transform of ft is a fs. So, this one is a nothing is here we write what? Here we write by definition of Laplace transform, by definition of Laplace transform, Laplace transform of ft equal fs equal 0 to infinite e to power minus st ft dt. Now, we differentiate this expression. Suppose here we write this one is a first equation. Differentiate first with respect to s. So, d by ds of a fs equal what? D by ds of a 0 to infinite e to power minus st ft dt. So, if we differentiate the left hand side and denote this one is a what? This one is a f dash s. This one is a what? This one is a f dash s. So, and if we differentiate the right hand side under integral sign, so this become d by ds 0 to infinite e to power minus st ft dt. So, there is a one factor means e to power minus st have a term of a s. So, we differentiate the e to power minus st. So, f dash s equal d by ds of a fs equal d by ds, t is treated as a constant, s is a variable. So, what is the differentiation of a e to power minus st? The differentiation of a e to power minus st is a e to power minus st into t, because t is treated as a constant. So, in the next phase we write what? We write the differentiation of a previous phase f dash s equal 0 to infinite e to power minus st into minus t, because the differentiation of e to power minus st with respect to s is e to power minus st into minus t, and ft dt, this one is treated as a constant. So, if we simplify, then this become minus time of 0 to infinite e to power minus st into tft and this tft and dt. This one is f dash s. So, if multiply by minus 1 on both sides, then this become minus f dash s equal 0 to infinite, minus minus become plus e to power minus st t ft dt. Now, using the definition of a Laplace transform, this one is nothing is Laplace transform of a tft, because if Laplace transform of a ft, then e to power minus st ft dt. Laplace transform of a any other function gt, e to power minus st gt dt. Here gt is a what? T into ft. So, Laplace transform of a t into ft is a e to power minus st t into ft. So, this one is nothing else Laplace transform of a t into ft equal what? Minus f dash s. So, this one is a proved. Now, what is the application of this property of a Laplace transform? So, if we have a Laplace transform of a ft, then we able to find out the Laplace transform of a t into ft by multiplying minus and differentiating the Laplace transform of a ft, means a fs. If we differentiate the fs, this can be generalized, means this result can be generalized like this one, means Laplace transform of a t into ft is a minus time of f dash s, or minus 1 to power 1 f dash s. If we means differentiate 2 time, means here 2 time differentiate once again, then we get what? After simplification we get the result Laplace transform for t square ft equal what? Minus 1 to power 2 f double dash s. And in a similar manner Laplace transform of a t to power n ft equal minus 1 to power n fns. Means if we have a Laplace transform of a ft, then we able to find out the Laplace transform of a t into ft, t square into ft, t cube into ft, t to power n into ft by differentiating the fs 1 time, 2 time, 3 time and 4 time by multiplying minus 1 to power 1, minus 1 to power 2 and minus 1 to power n fns. So, in this way we able to find out the Laplace transform of a t cube ft, t to power 4 ft and t to power n ft if we have a Laplace transform of a ft equal to fs. Now, we solve 3 numerical problem using the multiplicative property, means multiplied by integral power of a t. So, how we evaluate these Laplace transform, means if we have a Laplace transform for sin a t, then apply the multiplicative property. If we have a Laplace transform for e t, Laplace transform for e to power 2t, then how we find the Laplace transform multiplied by t, multiplied by t, multiplied by t square using the property of a multiplication by integral power of a t. So, here we solve the first problem. Let ft equal what? Let ft equal sin a t. Then Laplace transform, as we know that Laplace transform for elementary function, this one is elementary function, Laplace transform of a ft equal what? Laplace transform of a sin a t. Sin a t equal a upon s square plus a square, and this one is denoted by the capital Fs. Now, what is the Laplace transform of a tft? T into ft. T into ft equal Laplace transform of a t into sin a t equal what? Equal minus 1 to power 1 f dash s. And fs equal this one. So, what is the f dash s? f dash s equal differentiation of this one. So f dash s equal fs equal this one. So now f dash s is equal a into 2s upon s square plus a square to power 2 into minus 1. So this one is a f dash s. So if we put here, then what is the Laplace transform? Laplace transform of a t into sine at equal minus 1 into f dash s. F dash s is a minus 1 into 2as upon s square plus what? S square plus a square whole square. S square plus a square whole square. So this one minus minus plus, this become twice as upon s square plus a square whole square. This one is the answer. So once we verify the answer, this one is a correct one. Now similarly, we may able to find out a Laplace transform of a second problem. What is the Laplace transform of a second problem? What is the second problem? Laplace transform for t into et. Laplace transform for t into et. Laplace transform for t into et, e to power t. Here let ft equal e to power t and Laplace transform of a ft equal Laplace transform for e to power t, and again by the Laplace transform for elementary function, Laplace transform for e to power at is 1 upon s minus a. So this become 1 upon s minus 1. Here s is a greater than 1. 1 upon s minus 1. Now using the multiplicative property, Laplace transform of a t into ft, and here we assume that this one equal to what? Capital Fs. This one equal minus 1 f dash s. Minus 1 f dash s. So this become minus 1. Differentiation of this one is a what? Minus 1 into this become minus 1 upon s minus 1 whole square. S minus 1 whole square, minus minus become plus. So this become 1 upon s minus 1 whole square. So this one is a what? This one is a Laplace transform. Here we write by multiplicative property. By multiplicative property. Multiplicative property. Multiplicative property, and what is the answer? This one is a Laplace transform of a t into ft. Or we may write Laplace transform of a t into e to power t, because ft is a what? Ft is a e to power t. Ft is a e to power t. So ft is a t e to power t. Obviously here s is a what? S is a greater than 1. So here also we write s is a greater than 1. Otherwise Laplace transform does not exist. So what is the third problem? Third problem is a find the Laplace transform of a t square, means multiplied by t square e to power 2t. T square e to power 2t. T square e to power 2t. So here again let ft equal what? Ft equal e to power 2t, then using the Laplace transform of elementary function, Laplace transform of ft is what? Laplace transform of ft is a Laplace transform of e to power 2t, and this one equal 1 upon s minus 2, and provided what? S is a greater than 2. Now using the multiplicative property, now Laplace transform for t square ft equal minus 1 to power 2 f double dash s. F double dash s means differentiate with this function fs into 2 times. We differentiate this one 2 times. Here fs is a what? Fs is a 1 upon s minus 2. What is f dash s? F dash s is a minus 1 upon s minus 2 whole square, and f double dash s is a what? F double dash s, if we differentiate once again, this become minus minus plus 2 upon s minus 2 whole cube. So, what is the Laplace transform? Laplace transform now become t square ft equal what? Minus 1 whole square become what? 1, and f double dash s become 2 upon s minus 2 whole cube, provided s is a greater than 2. S is a greater than 2. So, this one is a what? This one is the answer. This one is the answer. This one is the answer. So, in this way we able to find out what? We able to find out the Laplace transform for t square into e to power 2t using the multiplicative property, means multiplied by integral power of a t in a function ft. If we have a Laplace transform for ft, here already we have a Laplace transform for ft, because we know that Laplace transform for e to power 2t by the Laplace transform for elementary function e to power at is a 1 upon s minus a, e to power 2 is a 1 upon s minus 2.